All right, today we're jumping right into the deep end of Geant4. We're talking about how you can truly make a simulation your own. This is all about user actions. But let's not think of them as just boring lines of code. Think of them as the tools that let you become the architect of your very own virtual universe.
I mean, that's really what Geant4 lets you do, isn't it? You're not just running a simulation, you're building a world from the ground up. You get to define the geometry, you get to dictate the laws of physics, and you get to decide exactly what you want to look at. So yeah, let's get into how you can really grab the controls here.
So here's the plan. First, we'll look at the big picture, your main toolkit. Then we'll get into the mandatory stuff, the absolute must-haves. After that, we'll see how you can observe what's happening, add your own custom info, and wrap up with some really cool advanced tools.
Right, so let's start with this core idea. Geant4 isn't this rigid, lockdown thing. It was built to be customized. It hands you this incredible modular toolkit that lets you tweak and tailor literally every part of your experiment. We're talking from the highest level, the big picture, all the way down to a single particle interaction.
Okay, so this control really breaks down into three main levels. You've got your mandatory actions. This is the bedrock, the foundation you absolutely have to build. Then you have the optional actions. Think of these as your cameras and your sensors, the things you use to see what's going on. And finally, you have user information, which is basically like putting your own custom sticky notes or data tags on everything. All right, let's dig into that foundation. These mandatory actions are, and I mean this literally, the architectural blueprint for your entire universe. If you don't do this part, nothing gets built. The simulation just, well, it won't even start. So it boils down to three key things you have to do, no exceptions. You've got to design the world, set the rules of physics for that world, and then you need to create the particles that are going to live in it. Simple as that. So that first step, designing the world, that happens in your detector construction class. And this is where you build everything. I'm talking shapes, sizes, what materials everything's made of. You can even define things like magnetic fields in here. It's basically your digital sandbox, your construction site. Okay, now for setting the rules. This is where the physics list comes in. And this is a really cool concept. See, there's no single magical physics model that works perfectly for every particle at every possible energy. It just doesn't exist. So what Geant4 does is pretty clever. It uses what's called a patchwork of different models. And it's your job to pick and choose or even build the right quilt of physics for whatever you're trying to simulate. And the great thing is you've got options on how to do this, from super easy to, expert level. The simplest way, just grab a pre-made validated reference list. It's like picking up the standard rulebook. Done. A little more flexible, you can use the factory to basically order a physics list from a catalog by name. Want to get your hands dirty? You can use builders to assemble your own list, snapping together pieces like Legos. And if you really want ultimate control, you can write your own laws of physics completely from scratch. And look at this. This is a perfect example of how easy it can be. This little code snippet right here, this is all it takes to load up a super powerful pre-validated physics list called FTFP_BERT. Seriously, in just 2 lines of code, you've just laid down a huge chunk of the fundamental physics for your entire universe. That's pretty amazing. Okay, so your universe is built, its laws are in place. Now what? Well, now you need to actually watch what happens, right? And that's where the optional user actions come into play. These are your virtual cameras, your sensors, your entire suite of instruments for collecting data. And you can observe things at totally different scales. You've got your big picture tools, the run and event actions. These let you do things at the very start or end of a whole simulation run, or at the start and end of a single event. But if you want to zoom way in, you can use the tracking and stepping actions. These let you follow a single particle's entire life from birth to death, or even get down to the microscopic level and look at every single tiny step it takes. Now this next one, this is a really powerful tool. It's called the stacking action, and you can think of it as the ultimate traffic controller for your simulation. Every single time a new particle, a secondary, is created, the stacking action gives you a chance to step in and decide its fate before anything else happens to it. So, how do you do that? Well, you classify each new track into one of 4 buckets. You can say it's urgent, which means deal with this right now, or you can mark it as fading, which is like saying, okay, put this in the pile and get to it after all the urgent stuff is done. You can even fade postpone it to the next event, or if you know it's just noise, you can just fade kill it right then and there. This is absolutely crucial for keeping really complex simulations from getting bogged down.
So, we're observing things, we're collecting data, but what if you need to add your own special information? Like custom labels or flags that you can check later during analysis? Well, of course, Geant4 has a way to do that. Let's talk about how you can attach your own custom info to things. This is where the G4 User Track Information class comes in, and honestly, it's fantastic. It lets you cook up your own little data object and basically staple it to a particle's track, and that info sticks with the particle for its entire life. Think about it. You could use this to flag where a particle came from, give it a unique serial number, or keep track of some special status. The possibilities are endless. And check this out. Here's a really powerful way to use it. This code shows how you can grab that custom info from a mother particle right when it decays or interacts, and then you can copy that same information onto all of its daughter particles. So what does that mean? The implication is huge. It means you can literally trace a particle's entire family tree through the simulation. Any particle that hits your detector, you can trace its lineage all the way back to the original particle that started the event. For analysis, that is an absolute game changer.
And it's not just particles you can tag. You can also attach custom info to regions of space. With G4V user region information, you can label whole geometric volumes, so your code doesn't have to do a bunch of complicated math to figure out where a particle is. You can just ask a simple question. Hey, is this particle inside the zone I called my calorimeter? It makes your code so much cleaner and easier to understand.
Okay, let's wrap up with a couple of advanced tools. These are for when you really want to get in there and fine-tune exactly how your simulation runs. Now, a quick but really important warning about killing tracks. You can just kill a track whenever you want inside your user actions. But, and this is a big but, if you do that, you've just broken the law of conservation of energy. Poof, that track's energy just vanishes from your universe. If you need to get rid of a track but want to make sure its energy is properly accounted for, added to the local energy deposit, then you have to use a proper G4 process for it, something like G4 user special cuts. It's a subtle difference, but it's absolutely vital for getting accurate results. Here's another cool feature that's great for keeping your code organized. You can actually register more than one user action of the same type. So let's say you have 3 completely different things you want to do at the end of every event. Instead of cramming all that logic into one giant class, you can write 3 separate, clean event action classes. You register all of them, and Geant4 will just call each one for you. It's awesome for modular design. There are a couple of exceptions to this, though. You can't have multiple stacking actions, and that makes sense, right? You don't want 2 different traffic controllers shouting conflicting orders about what to do with a new particle. And you also don't need multiple primary generators, simply because one generator is already powerful enough to create all the different particles you might need for an event. And that's our tour. From the non-negotiable blueprints to the high-tech sensors and advanced directors controls, you now have a much better idea of the toolkit Geant4 gives you. You really can architect a virtual universe that's tailored exactly to what you want to study. So the only question left is, now that your universe is built, what are you going to discover?